thank you, Anelda, for that introduction. When Anelda asked me to do this talk, she asked me to give a bit of a history of the Software Sustainability Institute, the SSI, and she also asked me to talk about a bit of our work. So I've chosen a couple of our campaigns that I would like to focus on, and I was trying to work out how this all connects together with the history and the different campaigns. And for me, really, it's around research culture. It's the effect that research culture has on research software. That's what ties this all together. And it starts, of course, with the foundation of this Software Sustainability Institute in 2010. So we set up the Institute on the back of a call that came from the Engineering and Physical Sciences Research Council, the EPSRC as we call it. And basically what happened is that the EPSRC were getting concerned about the amount of software they were seeing in their research and in the bids that they were receiving, because researchers didn't at that time have an organization they could turn to make sure that they were using the software in the right way, that they were using the software that was fit for research. So we applied to that call. We were successful, and we've been running ever since. The thing that I think is quite interesting is that the way that we have tried to support software sustainability has changed significantly over time as we've come across barriers, as we've learned new experiences, as we've kind of changed our methodologies. Because when we first set up, we thought, well, if we want researchers to start using software better, what we'll do is we'll get some of our software engineers and we'll push them out to big sort of headline grabbing research projects, and they'll work with them, and then they'll do such great work that the research projects will be these exemplar projects that everybody will want to emulate, and then that will change the way that software is used across the country. And we had this significant problem that when the Engineering and Physical Sciences Research Council funded us, they said, we want you to support all research, not just engineering and physical sciences. So we were 8 people, and we had 250,000 researchers to support. So that was quite, there's quite a scaling problem there. Obviously, just sending out software engineers to work on research projects just wasn't going to cut it. It wasn't going to have enough impact. It didn't scale well enough. So we had to change our methodology. So we invested quite a lot of time and energy into awareness raising. So a lot of people weren't aware of just quite how important software was to their work. They weren't aware the gaps in their sort of knowledge about software and how it's used, and they were definitely not aware of the impact of poor software on their research results. So we spent a lot of time on raising awareness. And once we started building this community around us from this, the next thing that really came across and next realization was that there was a massive skills gap. People were hardly taught software engineering at all as an undergraduate, and they'd start their PhDs and suddenly they were expected to be a professional software engineer overnight. And where did they get these skills from? This is where we created one of our mantras. So the SSI has various mantras, and this is my favorite, and it's collaborate, don't compete. So we realized as a small organization with a large number of people to support, it was pointless just recreating another training program when there were lots of them out there. So rather than creating a competing program, we went out and we looked for the one that people were using and that would work well for researchers. That was software carpentry. We became the UK coordinators for software carpentry, and were one of the reasons that software carpentry is so prevalent in the UK and in Europe now. We really supported the development of them. And we started doing lots of training. We now train thousands of researchers every year. I can't remember our latest numbers. It's something like 14,000 since we started. So we could start building up the skills base, so people knew the techniques and to use, and they could understand how to use software better. And then we realized that many of these groups were in communities that lacked support. So we started trying to strengthen these communities, because if we could build a community around a piece of software or around a technique or around a region or disciplinary area, then they become self-supporting, and we don't have to do that support anymore. So it was one of the ways that we could build sustainability into our work. And then finally, and this is the most recent development, we realized we were very much in the policy making area of research, because a lot of the things that we wanted to change to make software better weren't supported by academic policy. And that's policy coming out of universities and other research organizations, policy coming out of funders, and also policy coming out of government. So we had to start impacting that policy if we wanted these things to change. And that sort of brings us up to date. That's what software sustainability is for me now. But the big realization we had was that if we wanted this to become, the default behavior, if we wanted people to start really following these practices, not because they were told to, but because that was just the way that the community worked, then we were very much in the business of research culture change. And that's where we needed to start thinking about how we could change culture. So I've got a couple of examples. One of them is sort of one of the ones I'm most proud of, that we made a significant change in the way that research is done around the world. And the second one is about something that I actually heard when, just as I entered the Teams room, somebody was saying, well, software isn't used as a sort of, isn't collected as a research output. Well, that's exactly what we are starting to work on. So I want to talk about these two campaigns and tie them together. So the first one started off from something we were asked about all the time when we set up, and that was, is software important? Now, it seems like a facile question to ask. Is software important to research? Everybody knew it was, but our realization, the key realization that changed behavior around this area, was that we noticed that policymakers were hamstrung from making changes, from changing policy to support software, because they didn't have the evidence of how important software was. It was one of those things everybody knew, but nobody could evidence. So we went out and collected the evidence. Now, I'm a laser physicist, and I ended up doing a lot of social science. That's a very dangerous place to put a physicist. But we learned a lot over the time of doing this work. So we ran a survey over 15 Russell Group universities. So the Russell Group being the research-intensive universities, the big research-intensive universities in the UK, collected over 400 responses from people from all disciplinary backgrounds. And we found that 92% of them said they were using research software. So this was software used to generate results. And more importantly, 69% said that software is fundamental to the generation of results. So if you lose the software, you lose almost 70% of your research overnight. This was a really impactful study because for the first time, policymakers could go and they had the evidence to be able to write policies that supported better use of software and research. And we've seen that grow ever since this study was published in 2014. And in the current era, we now have software, we have policies that are supporting sustainability of software, maintenance of software. We have fellowships for people who work just with software and research. We have a huge amount of impact and investment going into this area, and a lot of it started because we managed to unshackle the policymakers by providing them with the evidence they needed to make those changes. But the thing that really impacted for me was, well, who's writing all of this software? Because what we did know at the time was there was no career path for people who develop software or engineer software in academia. And so we looked into this. And if you've got so much software being used but no career path, somebody is writing this software. And who was it? It was the saviors of research, postdocs. So what we found was, when having to deal with this issue that there wasn't a career path for the people they needed to write the software, principal investigators were turning to what they knew, which was a postdoctoral position, and they could hire somebody in. And they dealt with the immediate problem, which was they couldn't get access to their skills. But they created a bigger, more pernicious problem, which was they then locked a person into a career pathway that wasn't suitable for them. So these people were spending their days writing software, but the success of their careers was based on the amount of papers that they weren't writing and the amount of research funding that they weren't applying for. So we locked them into dead-end careers, and we lost lots of really good people this way because they would go off and work in industry where they were being recognized and rewarded. Our realization here was that we needed a new career path in in academia. So we at one of our events, the Collaborations Workshop back in 2012, we came up with this job title, Research Software Engineer, because it combines the research and expertise in research and in software engineering. As I say, we're all computer scientists and physicists. We're not very novel when it comes to naming things. Just munch them together. And we led a campaign to try and get this this role recognised across the country, and I had high hopes that we would manage to get maybe a few hundred, but it turned out to be way more popular than that. And it's now many more than 10,000 research software engineers around the world. We have 14 national associations, including our own learned society in the UK. So this campaign went global very quickly and was adopted very quickly. I would love to say that was because we are so good at running campaigns, but it was largely because it had to happen. Because of all the software that was out there, we needed to see this rule being adopted. Now, for me, the biggest impact within the UK was the change in universities. So we now have Research Software Engineer is the default title for anybody who works with software in academia. We see whenever we see roles being supported both within research projects, there are 41 universities and research organizations with RSE groups. So I run one of these in Southampton. Basically, you pool your research software engineers together and then hire them out to research projects across your university. And it's a really good way of dealing with the problem of ensuring that there's enough software engineering expertise out there to work in a university. And we're all through research. Research policy. So for example, RSEs can lead research bids. They certainly are included in the author lists, in papers, and all this sort of stuff. So it's become a part of the fabric of UK universities, and that was the real success. So this, for the first time, allowed us to sort of really deal with that skills gap problem that I was talking about earlier on, because rather than expecting researchers just to start adopting a whole new skill set, as though we kind of used to deal with it as though researchers could happily become software engineers themselves, and many of them can. I'm not sort of saying they can't do that, but we shouldn't be reliant on researchers being sort of superhuman and having skills in absolutely every single different area of what are very large, complex, and diverse teams that we need in research nowadays. So I started thinking about how we could change things for more than just research software engineers, and how we could start really getting a focus on software as a sort of a key research output, a first-class research output from research. Because I realized that if we don't care about software, then we're not going to be supporting it. So this led me to start thinking about, like, well, what do we care about as researchers? What drew us into this field? And for me, this is all about, well, discovery. I think most people are brought into the research world because they've got that slightly noble goal of wanting to push the boundaries of human understanding. That's the exciting bit about being in academia or being in research. But obviously, it's more than just discovery. We want to make sure that we're discovering the right things. We care about reliability. That should be a core part of our goals. And for me, if you care about reliability, then you really got to care about reproducibility, because that's the easiest way of showing that your results are reliable. And again, I think openness and transparency is the best way of allowing reproducibility. So being open and transparent, sharing your working. So this is what I cared about. This is what drew me into research. And when I talk to colleagues and friends in the community, this is largely what I find other people care about as well. So if I was to get people to think about software and to care about that, I needed to now work out, what do research organizations care about? And this is incredibly difficult, and really where it comes into our work in changing research culture. Every single university is different. They've got different structures. They've got different management sort of structures. They've got they're obviously geographically different. They've got different specialities. So it's really hard to work out one specific way that you can sort of understand what an organization cares about when it comes to research. That was right up until I realized that the UK actually does have an advantage over a number of other countries. Not many people in the UK see it as an advantage, and that's because we have something called the Research Excellence Framework. So this is you wonder why I'm telling people in South Africa about a bureaucratic process that takes place in the UK, and that is because it just happens to be that we have a framework for this, but the issues that it uncovers are absolutely universal, and they apply across every single research economy in the world. So I'm going to tell you a bit about the Research Excellence Framework, and then I hopefully will persuade you that this is relevant to you as well. So basically what this is every 7 years we assess the outputs from universities to understand the impact that they're having on research, the excellence of the research that's coming out of the universities. And I was saying about what do universities care about? Well, the Research Excellence Framework talks directly to the thing that every university cares about, regardless of the diversity across them. It talks specifically to money. So on the back of this exercise, which, as I say, takes place every 7 years, £2 billion per year are dispersed across UK universities. So I think that's something like 46 billion rand. So huge amount of money is up for grabs if you can get your Research Excellence Framework submission correct. So the thing that we know about it is that universities treat it very, very seriously. So it's the perfect place to start if you want to understand what a research organization cares about. Right, so that's the end of that bit. So sorry about the slightly boring sort of look into a UK bureaucratic process, but I'm now going to talk about my journey in understanding it and what this led me to work out. So I went off and I looked at the submissions that universities put together, and what they do is they submit outputs. And I had not been ref returnable, so I wasn't eligible to take part in the ref. So I was trying to work out, what this involved, and I investigated. And these are the outputs that you can submit to this exercise. And I was really happy, actually. It's full of things that you'd expect, so journal publications and books and bits of books. But then there was lots of things that I didn't expect, so artifacts and patents and compositions. And then I had a slightly chilling moment as I realized that under digital artifacts, category G was software. And I mean, this was incredibly professionally embarrassing for me because, I was director of strategy at the Software Sustainability Institute. I'd been working in the field since 2007. This was now 2019. And I had no idea that software was included in our big national research assessment. And the research that this could allow me to do was phenomenal. This is a treasure trove of data. With these results, I could work out what universities actually cared about, how they qualified what good looks like for software. I could see which universities were submitting the most software. I could even link that potentially to whether universities with research software engineering groups or good support for research software engineers were submitting more software or better software or whatever. It was very, very exciting when I realized the data that I had to work with. So before I got too excited, I realized I couldn't plan anything until I had to look at the outputs that we had to play with. So I went through the last 3 exercises and I plotted the outputs that were submitted to this exercise. And here's the chart. Now, those of you with good eyesight might notice a slight skew in this data set. And that is that publications given 21 different categories of research output, representing the huge diversity of different work that's fundamentally important to research, universities chose to put everything into their publication categories. So it started off at 96.8% in the 2008 exercise. It went up in 2014. It went up again, even though there was hardly any space in 2020 and the 2021 ref. In that ref, in 2021, there were 186,000 research outputs were submitted. Now, we know that 69% of them are fundamentally reliant on software. So out of that 186,000 outputs, how many were software outputs? 11. And this is a huge disparity, and one that nobody had really investigated previously, which was kind of shocking. And I do this talk to policymakers all the time, and I have to get across this disparity in the way that the things that we rely on in research and the way that we measure success in research, which is via publications. So I've got a couple of examples here. So if we think of publications as the Burj Khalifa, the tallest building in the world, then software's a matchbox, and it's not even a matchbox standing on its end; it's standing on its side. And I could do it in lots of different. I've spent a lot of time on this. If publications are a blue whale, then software is a dachshund. And so this is the way in which research is hugely reliant on a range of different outputs, and the way that we actually measure the success of that research is via something that is not directly related to the outputs that are important to it. And so you might push back against this. You might sort of think, well, what's the problem with papers, with using those as basically the only metric of research success? Well, I'm going to give you a couple of examples. There are reasons why I think that this is a problem, and why it harms our ability to conduct research. And the first way I want to talk about this is through what I call the Venn of academic importance and recognition. So we have the people who are vital to research. So without these people, there's no research. And we have people who are named in publications. And as we've seen from the REF exercise in the UK, but this is the universal part, this behavior is across all research economies in the world, we tend to use publications as the only metric of success. So now we need to start putting people into this Venn. So we know traditional academics, now they're sitting quite happily in that central segment there. They are both vital to research and they are named in publications, so they get to share in the success of the research. The trouble is, when you look at all of the different roles that we rely on, they tend to end up in this blue segment. There are definitely exceptions, right? But they are exceptions. They are not the default behavior that we are trying to change. So all of these people we rely on, so research software engineers, certainly, and data stewards, prisms, the new roles are very much in this segment. But I really want to point this out, that technicians and librarians, roles that have existed since we've had research, are also in this segment. What happens if you don't allow people to share in the success of the work that is being done? You demotivate your workforce, you make it difficult to recruit the best people, and you make it phenomenally difficult to retain the best people in research. We want to keep these people in our organizations doing the best kind of work. So that's one of the major issues. And the second one for me is that it creates a very perverse incentive structure. So we are incentivizing only the end product of the research and not the journey to that research. If we do that, we create an environment in which we get people to rush to publication, to get to publication as quickly, to publish as much as is possible, and to overlook all of the intervening steps. Now, software obviously is what I care about here, but there's many other things as well. Everything from data to methodologies to various other aspects of research that aren't being getting the recognition they deserve, so they're being overlooked. And this incentive structure is the reason why we've had such trouble getting software to be treated more seriously within organizations. If we could get this right, if we could recognize all of the outputs and all of the people needed to conduct research, we'll certainly make research more equitable, because we're relying on people currently who aren't getting the cut of the success, but we'll also make it more effective. Because if we can motivate the workforce, if we can engage the workforce because they know that they're important to the research and because they're sharing success, then they will do better work, and we'll advance research across the board. The next problem for me was how can we make this change happen? It's great to sort of come to that conclusion. It's very difficult to shift a country's thinking around research in any significant way. So, and the way that we've done it in the SSI is we launched something called the hidden ref. So we've got the mainstream ref, we know what that is. Let's talk about all of the stuff that's happening in research that's vital but unrecognized. And we'll do that through a competition. So we set up the hidden ref in 2019. We've run 2 competitions since. We've had over 120 applications for each competition from more than 60 different universities across the country. The rules were actually fairly simple. We said, you can submit anything you want, anything that is vital to research, but is not getting the recognition it deserves. And we really want you to submit everything. So I think we have something like 30, just over 30 different categories of output that can be submitted. There was one rule, and that was you weren't allowed to submit publications. So publications are banned. They get recognition enough. The hidden ref was all about things that aren't publications. And now that we've run this a couple of times, we've seen some really significant changes happening in research, in the research community and in research culture. So people were getting back to us about after winning the competition. They were saying that by winning the competition, it gave them the sort of the empowerment, and encouragement to go off and lobby for change within their organizations. We found that some people were getting back to us and saying that they were using their win in the competition to support their promotion casework, and they were getting promoted partially on the back of having won this national competition. So they were getting that recognition they deserved. And then my favorite example was one person got back in touch with us and said that they used their win in our competition to make the case with their university that they should be the focus of a ref impact case study. That was successful. It brought millions of pounds into their university. So in a really weird roundabout way, after we had recognized their work, their university recognized it, then the mainstream recognized it, and their university got more money out of it as well. So it was a really nice story for us on that one. On the back of these kind of successes that were happening, we started getting approached by a number of different organizations. There's about 32 of them now. And these are our supporters. And they range from, the Royal Society of Chemistry, very old organization in the UK, right through to things like the Technician Commitment and Bioimaging UK that are representing old communities and newer communities. And what we found was each one of these organizations was lobbying for exactly the same change. They were lobbying for a better understanding of the impact of people's work, regardless of the fact that they weren't doing traditional academic roles, and supporting this concept of team science. But they were all lobbying for that change within a particular area, for a particular group, or for a particular discipline. And by bringing them all together, the hidden ref has this ability to push for change across the board and across all research disciplines, and we're having a lot of success. So the way I wanted to really show this success was, this is like, although it's a tweet, it represents one of the high points in my professional career. And it's where we realized that our lobbying for a change had been successful, and the national competition changed on the back of the work that we've been doing. So when they talked about the next ref, which is coming up in 2029, they've changed the rules, and they've said that this will allow the submission of outputs by any staff member, including non-academic staff. So for the first time since 1986, the program in the UK is now allowing everybody who's a staff member in a university who's conducting research to take part in the assessment exercise. It's a huge change. It means that people who are contributing to research can now get success, even if they're in the wrong job family, which is a non-academic job family. But I also think it's a lovely microcosm of the issue that we are facing, and how deeply set research culture is. If you look at the words that they use to actually announce that change, they say this will allow the submission of outputs by any staff member, right? So that's any staff member, including non-academic staff, who it turns out are also staff. This represents just quite how ingrained in our psyche that this idea that there's a separation between academic and non-academic staff in universities, and if we've got to get rid of that if we want to advance research. So just got a couple of minutes left, so I'll just want to finish up by saying where we see the future going in this direction. So this was a volunteer-run campaign that we ran from the Software Sustainability Institute. At the start of this year, we were asked to submit a bid by Research England, and they're the ones who run the mainstream ref. So we were being asked to come into the tent by the people who are funding the work that's going on in the UK. And we won 3.4 million to run the hidden ref over the next 5 years, and we're using that money in lots of really useful ways. So first of all, we're doing a lot of this. We're going out and we're talking to people about the work that we're doing, and the fact that there is a better way to do research that will be more efficient and more effective. And it's actually quite a simple change when it comes into it. It's about recognizing things like software and other research outputs, and recognizing other research roles like research software engineers and other ones. We're having to spend a reasonable amount of our time on writing on guidelines for assessment. So when it comes to, how do you judge what good software looks like, or how do you judge what a good composition or good data looks like, then there isn't really very much out there to guide universities and assessment panels, for the ref. So we're writing that, and the way that we're doing that is we're putting together expert groups from across the country, and they are writing the guidelines. We are then taking those guidelines and we're putting them into our competition. We're feeding back to the mainstream ref so that those guidelines will be used, and we'll be publishing all of this openly, so anybody can benefit from the work that we're doing here. And then we're spending a lot of our time going into universities around the UK and teaching them about the importance of these outputs that are generally submitted to the ref, so software and data, and also how to assess them. And the entire reason we're doing that, and I really want to tie this back to so what I said a little bit earlier on, is that if we recognize everyone who's vital to research and every output that's vital to research, then we'll advance our ability to conduct research. And that really ties together, that comes to the end of our conclusion about how we've changed in the Software Sustainability Institute, moving from an organization that was very much just about pure software engineering, and the realization that without changing research culture, we weren't going to change the way that researchers were working. And ultimately, our goal is about advancing research across the board. And with that, I'll say thank you.
Thank you so much, Simon. I'm grateful to say that we have here today all staff, including non-academic staff, at the event. As you were talking, I could really look at the audience and see the people that you were talking about. So I think we've got the right people in the audience. Are there any questions for Simon?
Thank you so much, Simon. I believe I'm struck, like everyone else, about the disparity you mentioned between research outputs and the software. And I was wondering to what extent people report software as critical for their research when referring to things like spreadsheet software or a word processor, and to what extent we're really talking about the kind of, let's say, bespoke systems engineered specifically for research, which I think is what we typically have in mind when we're thinking of research software engineering. Do you think that explains some of that disparity? Do you have any gut feel of what portion of that could be explained that way?
So when we did the survey, I'm casting my mind back to 2014 here, right? So I will be stretching my memory a little bit. We defined research software, and we defined it as any code that you'd written that was used to generate results for your research. We specifically said, not the use of software for writing papers or something else, or browsing the web, like finding evidence. So we did cut out, by definition, anything that was to do with, a use of software that didn't lead to the generation of results. So, but spreadsheets are the one that sits right on that middle point. Now, I really wish that we didn't have to sheets, because I think they're not reproducible means of doing research, but we all still use them. Personally, I would say if a spreadsheet was complex enough where it was actually doing some research, then yeah, I'd probably just sneak that in as research software, but I would feel very uncomfortable doing so.
And if I may just briefly, let's say bespoke but off-the-shelf research software, I mean, does that maybe explain some of it?
Yeah, so some of it could have been off the shelf. So people using I don't know, NVivo or something like that. But when we looked at people who were writing their own code, it was 56% of the respondents said they wrote code, anything from a couple of lines script to a fully fledged software package is how we defined that. So a significant proportion are writing code as well, 56%. So I think the thing that I find and we've been doing this since 2010, is there's a huge amount of very small scripts being written to do little bits of data analysis that are kind of overlooked when it comes to publications, when it comes to people thinking about what's important to their research. But without them, there's no reproducibility, because you can't actually reproduce the results. So those few line scripts may seem unimportant, but they are vastly important, and they're sort of lost part of research.
So I think I just want to follow up on that. So I guess the reason why publishing software is important is the reproducibility of your research, right? Even though
yes,
that might be very specific to the research that you're doing and not useful for someone else. Is there any other reasons except reproducibility that we might want to publish the software? I guess that's my questions.
So I think the main one for me is the fact that you may think it's not useful for somebody else, but it's very difficult to make that judgment call because you don't know other people's research. A lot of, personally, and this is my politics coming out slightly, but like I think that if you're using taxpayers' money to conduct research, you should be absolutely maximizing the return on that investment. So one of the other reasons, aside from reproducibility, and I will say, like, reproducibility alone is a big enough reason for doing it. But one of the other reasons is reusability. So you're publishing code that somebody might actually see and think, actually, I'm working in that area, and that would be a really useful. I could reuse that or build on it, add functionality, and they could advance their own research without having to duplicate the effort that you've invested. So I would say that's my second biggest reason. But I'd argue that reproducibility alone is enough.
And maybe just to say, when we talk about publishing research software, there are many ways to publish research software. There is research software papers, which, for example, there's the Journal of Open Source Software and the Journal of Open Research Software, or Journal of Research Software. And both of those are DHET accredited and open access. So those are two avenues. And I don't think I've seen a single African software paper in either of those two journals since its existence. So there are avenues to get papers about your software if your institution is still highlighting the papers first, and then also get your software out. Then there's also, of course, getting your software onto repositories like GitHub, GitLab, Bitbucket, and those can be licensed, closed, open. So lots of conversations that we can still have about what does research software publishing looks like. But Simon, thank you very, very much for your time.
But I just want to say that it's fantastic what you're doing, and I really hope you enjoy the day. And if there are any sort of questions or follow-ups, then I've got my email address on the slides, and I'll share the link in the chat.
Excellent. Thank you so much. Good luck with the
Thank
travels.
you. Thank you.
Okay.
Bye-bye.